Welcome, welcome. We're going to do question 182 and 183. So let's do it. An alumni association from a university finds that 30% of their members attained advanced degrees. 50% obtained bachelor's, and 20 did not graduate. So it looks like this information we collected includes everybody they talked to. Now it says the mean income of a graduate with an advanced degree is $75,000. The mean income with a bachelor's and with someone who didn't graduate with a degree, $36,000. From past results, the alumni members donate 5% of their income. So we have to figure out what their income is, and then we're going to multiply by 0.5 in order to figure out what their donations would be in total. And it helps if we know how many people are making these donations if they were randomly selected. So we say to ourselves, here's my formula sheet, and here's this expected formula, the summation of x sub I p sub I. So the probability that you're advanced would be 0.30. The summation of x sub I, p sub I would be the first x value, which is 75,000, times the probability that you're making 75,000. And then the next is half of them are making on average this, and 20% of them are making that. And so this is what we should expect any old graduate or non-graduate, any old person from the university to make. So I'm going to go ahead and do the math. And I get $56,700. So that's on average what we'd expect a person from this university to make. And that number seems to make sense, that would be the average. Now that I know, how much would I expect to get from 50 people in general? So I'm just going to multiply that 50, and I end up getting 141,750, and I'm pretty excited because that's E. Next question. It says, in order to determine the dexterity of handedness, 10 people were asked to roll a dice with one hand and make a tally mark with the other for 60 seconds. Now this is kind of interesting. So I'm going to draw a little picture of what happened. So every one of us has two hands, a left hand and a right hand. So it says, in order to determine how dexterous we are, which that is just, which hand are we better at using than the other hand, 10 people were asked to roll a dice with one hand and make tally marks with the other hand. So either the person was asked to roll a dice with this one, so I'm just going to put a little picture of a dice, and then this one, you were going to have to hold a pencil and make little tally marks. That would look like that, little tally marks, right? Or vice versa, you were asked to roll a dice with this hand, put little dots on my dice, and hold a pencil and make some tally marks. Okay, so let's keep reading. In order to determine which hand we're better at using, we asked 10 people to roll a dice with one hand and make tally marks with the other for a time. So we had a timer on this of 60 seconds. Now it says the subjects were then asked to use the other hand. The hand that each person used first was decided by chance. So we could say person one, we don't know which one they used first, but this was the number of tally marks they were able to make in that 60 seconds. And you can see the other hand. So the hand that each person used first was decided by chance, and the number of tally marks made by each subject is shown in the table. Notice that they first did it with whichever hand. So let's say you flip a coin and you get heads, and let's say this is heads, tails. So if you flip a coin and you get tails, you're gonna start with the dice in your left and then do tally marks, and then you're gonna flip-flop this. And if you get tails, you're gonna do that second. So first you do this with that, and then if you end up, the other person is gonna do the opposite. If they get heads, they're gonna start with the dice in this hand. You get the point. So now what you should be realizing is finally we get an example of a matched pair, because we're using our own self for the other. We ourselves are doing the simulation. These 10 people, they're doing it with their left hand first if they got tails, and then they're doing the same behavior with the right hand, or vice versa. If they got heads first, they're starting with the dice in the right hand, vice versa. Is this making sense? I think that would probably be more accurate. If you get heads, you do this and then you switch. If you get tails, you start with this and then you switch. So notice that in a match pair design, what you're calculating is the difference. So that's actually one statistic. We're not doing a 2-sample test. That's the instance where you're doing one sample, because you yourself are one human being. And what you really want is the difference between your two hands. So here, if I start with right minus left, I'm down 3. I'm down 13. I'm up 19. I'm up 1. I'm down 12, down 12, up 4, down 11, down 14, up 14. So right off the bat, it looks like sometimes my right hand is faster and sometimes my left hand is faster. So I'm already presuming that I'm probably gonna get a pretty high p-value, so because it kind of seems like there isn't a preference for hands. But this is what I'm gonna do my significance test on. So I'm gonna say H sub O would be the average difference, mu R, the right hand is equal to the left hand, and it looks like they're pretty equal. And if you believed that there was a preference here, either you're going to have to say that they're not the same, meaning you are handed, one hand is preferred over the other, or you may have to try a direction. Maybe you think that the mean should be greater. I should be able to make more tally marks with my right hand than my left. I don't see a direction of any sort here, so I'm gonna have to pick this one and do my stat test. I'm gonna turn this thing on, go to my home screen, and I need to put this data in the calculator. So I'm just gonna call this hand, H-A-N-D, and I already did the math. You could put the data in here and have the calculator do the math for you. I'm just gonna put the difference data that I calculated here in. So on my table, I called this hand, and I'm just gonna put -3, -13, +19, 1, -12, -12, +4, -11, -14, +14. Okay, so I put in all of these differences in my calculator, and now I'm just gonna do a stat test. So I can go to menu, stat test, and since I don't know the standard deviation of this information, I'm gonna have to do a t-test. And I actually entered the raw data, which it's pretty rare that I do, but I actually have my data now. So mu sub 0 would be that they're equal to each other. Oh, and I don't know. I'm not sure what to put in for that. I did this yesterday, and I'm not exactly sure what happened here, so pause for just a second. I'm going to put 0, that there is no difference between the two. Assuming that, another way to write this would be UR minus UL would be 0. There is no difference. What's the difference? Okay, yeah, that's probably what I want to do. So sorry if I took a minute to think about it here. I'm going to put 0. And then my list here is the word hand. And so these numbers, if they were exactly the same, would in fact be 0. And those are my list. Yep. And then I believe that my alternate hypothesis is just that it's something other than 0. So I'm just going to leave that, hit OK, and go up here and look at my p-value. I get a p-value of 0.493. And I notice, yep, here we go. And so I did get a pretty high p-value because it does appear as if sometimes the left hand is better and sometimes the right hand is better. Thanks for joining us.